we have a random sample of the number of bottles sold per day of raspberry iced tea, and it's given in this table below. Now, a couple of things. Notice that it does say a random sample. So we know things like our mean would be an x bar. Our variance would be an s squared because we have a sample. Now, we can actually use our calculators because I've told you that we could use calculators this semester. You don't have to show all work, especially for variance. So you can use the calculator to do the calculations for you if you know how to use your specific calculator, which I've showed you in Canvas. There's multiple videos for that. Just pay attention to whether this is a sample or a population. Now, remember, mean, you're calculating it the exact same way. You add up all the values, and then you divide by how many you have. So if I add up all of these values, I'm going to get 515, and I'm going to divide by 10 because I have 10 different ones. And so that's going to give me 51.5. And I am going to keep the 1 decimal place because notice that my data is in whole numbers. And I always want to give myself a little bit of buffer room, so I always want to go 1 decimal place more than what my data is. So I'm keeping to 51.5. Now my median, we're going to calculate, and I can either mark off 1 for 1, or I can do the location formula, 0.5 times 10, which is 5. Remember, if you get a whole number here, you go to that position and the next position and take their average. If you're using the location formula for mean, percentile, quartiles, anything like that, you don't just go to that position if you get a whole number. You have to go to that position and the next position and take their average. So I'm going to get 48 plus 49 divided by 2 is equal to 48.5, and do not round. Leave it as is. Mode, that's the one that occurs more often than any other. And in this case, they all occur 1 time. So we have none. Now again, you can use the formula for variance, which says that you're going to take each value and subtract the mean, square those values, and then add them up, and divide by an n minus 1, so in this case divide by 9, and that will be your variance. Or, in the calculator, you can find out your standard deviation, because your calculators will give you an S, which would be 15.6, and then you can square that, which would be 244.3. Remember, variance is just a stepping stone to get us to standard deviation. So most of the time you're not even going to be asked about variance or anything. Quartiles, Q1, Q2, Q3. Remember that they're quarters, they're locations. So location will be at 0.25 times 10. So you'll get 2.5. If you get a decimal for location, you always round up to the next position. So Q1 will be at position 3. So the number in position 3 is 46. So my Q1 is 46. Q2, which is also the median, we had already found at 48.5. Q3 we need to do location at 0.75 times 10, which is going to be 7.5. So I go up to the 8th position, and I look for the number in the 8th position, which is 1, 2, 3, 4, 5, 6, 7, 8, which will be 58. So Q3 is at 58. So pay attention to those rules for location. Now, to identify any outliers, we have to calculate our interquartile range, IQR, which is Q3 minus Q1. So that's 58 minus 46. 58 minus 46 is going to be 12. Then we have to find what our lower boundary is. And for our lower boundary, we find Q1 minus 1.5 times our IQR. So that's going to be 46 minus 1.5 times 12, which will be 28. Now, if you get any decimals, just leave those as is. Again, this is just a boundary. It's not a data point or anything like that. It's just helping us find any outliers. Our upper boundary will be Q3 plus a 1.5 times an IQR. So that's going to be 58 plus 1.5 times 12. And that's going to give me 76. So these are my two boundaries. So let's go back up to our data, which is already in order. And so if I look at my data, my lower boundary was at 28. So 28 would be between 22 and 45. My upper boundary was at 76. So it's right here, somewhere between here. And if you think about this, everything in here is within those boundaries. All of these numbers are within those boundaries. Everything on the outside is considered an outlier. It's on the outside. So for this data set, we actually have two outliers, 22 and 83. They are both considered outliers. So we do have outliers of 22 and 83. And we denote those on this box plot. So I'm going to draw a number line. And I'm going to start with 20. And I'm going to go to 85. So I'm going to say 25. Here's 30. 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, and 85. And I can put 90 on here. But I just have to go from my lowest value, which was 22, to my upper value, which is 83. So I'm going to put my outliers on here as X values or stars, either way. So I'm going to put X's on here for my outliers. Then I'm going to put vertical lines at my quartiles. So at 46, I'm going to put a vertical line. At about 48.5, I'm going to put a vertical line. And at 58, I'm going to put a vertical line. Then I'm going to go look back at my data. Notice where I drew my boundaries. I look at the values just inside those boundaries, 45 and 65. That is where I'm going to put my dots at. So I'm going to put a dot at 45, and at 65. And then I'm going to draw a line to my box. Notice I'm not drawing it to my boundaries. My boundaries don't go anywhere on this box plot. It's strictly the data that is included. If I did not have any outliers, in other words, if my 22 or my 83 was not an outlier, I would go all the way to my maximum value or my minimum value. I would go to that actual value. But in this case, I do have outliers, so I have to go to the number just inside of the outlier. So practice this one, practice the next one, and if you have questions, let me know.